Hello students, in this video lecture we will solve the MCQ related to electric flux and Gauss law. Okay, our first MCQ is dimensional formula for electric flux. Okay, first of all we have to uh, write the formula for electric flux. Okay, so electric flux is denoted by phi and the formula is phi equal to E dot A. Okay, and another formula for electric flux is regarding to Gauss law, and that is phi equal to q by epsilon 0. Okay, but from this both formula, to find the dimensional formula, this formula E dot A is easy for us. Okay, because we know the dimensional formula for electric field and area. Okay, now if we don't remember about the dimensional formula for electric field, then we can simplify it into force upon charge into area. Okay, so now we know the dimensional formula for electric force, and that is m1 l1 t minus 2. In denominator there is a charge, so dimensional formula for charge is a1 t1, and here is area. Okay, so see, don't be confused. Here is A stand for ampere, while this A is for area. Okay, so dimensional formula for area is L2. Okay, so now simplify it. So here we have M1 L. See, here L1 and here L2. So total L raised to 3. T raised to minus 2 and t raised to 1. So when it goes to upside, it will become t raised to minus 3. And when this A, remember this, okay, A stand for ampere, goes to upside, then it will be A raised to minus 1. So this will be the final answer for dimensional formula of electric flux. So our right answer will be option D, M1 L3 T minus 3 and A minus 1. Second MCQ is, there exists an electric field of 100 Newton per Coulomb along the Z direction. The flux passing through a square of 10 cm sides placed on XY plane inside the electric field is. Okay, so here what we have to find, we have electric field and side length of side of square. So here we have electric field, and that is 100 Newton per Coulomb, and length of square, that is 10 centimeter. So area will be 100 centimeter square. Okay, now see what we have to find. We have to find the electric flux. Okay, flux passing through this square. Okay, so now see here, we consider this direction as a z direction. So electric field along this z direction, so electric flux is similar into direction of z axis. So that is 100 electric flux in the direction of z. So x and y are perpendicular, so actually plane of xy. Okay, not xy, x and y, so plane of xy. Okay, here the side of square is 10 centimeter and this also 10 centimeter. So this square, okay, this square is perpendicular to this electric field. Okay, so now the area vector of this square, okay, area vector is of this square is also in the direction of z axis. So here the angle between electric field and area will be 0, as both are in the same direction. So to find the electric flux, we have formula E A. Okay, so E is 100. Now see, area is 100 centimeter square. Okay, so 100 centimeter square, so actually electric field is in the SI system, so we have to convert this area into SI system. And how can we convert? By multiplying this with 10 raised to minus 4. Okay, so this will give us an answer 1. Okay, Newton meter square per coulomb. So our right answer will be option D, 1 Newton meter square per coulomb. Okay, now don't be confused by seeing different units. Okay, both Newton into meter square per coulomb and volt into meter, both are the unit of electric flux phi. Okay, so don't be confused in unit. So this is our second MCQ. Next MCQ, the inwards and outwards electric flux for a closed surface are respectively phi 1 and phi 2. Then how much charge is inside the surface? Okay, so we know that in a closed surface, okay, any closed surface, okay, there is a inside the charge is q, then electric flux phi equal to is given by q by epsilon 0 according to Gauss law. So from this formula, charge is equal to flux phi into epsilon 0. Okay, so we have to use this formula to solve this MCQ. Okay, so from given options we can say option A, B and C are not relevant to our answer. Okay, because from this formula we can see charge is equal to flux into epsilon 0, while in this all three options flux by epsilon 0, that is not valid for charge. Okay, so our right answer will be option D. According to this formula, charge is equal to flux into epsilon 0. But here see why this phi 1 minus phi 2 only, because here it may be phi 2 minus phi 1, or it may be also phi 1 plus phi 2, but here we have only phi 1 minus phi 2. So why this phi 1 minus phi 2 only? To understand this we have to remember that the inverts, okay, we have to consider inverse flux. Okay, inverse flux is negative and outwards flux is a positive. Okay, in any closed surface inward flux is negative and outward flux is positive. Okay, so here inward flux is phi 2 and outward flux is phi 1. So resultant flux will be sum of both phi 1 plus phi 2. Okay, but here phi 2 is considered as negative, so net flux for this closed surface will be phi 1 minus phi 2. Okay, so this will be our net flux. So net flux multiply with epsilon 0 gives q, means charge. So our right answer will be epsilon 0 phi 1 minus phi 2, and that is in option D. Okay, next MCQ, 8q charge is placed on any vertex of a cube. The flux link with this cube is dash. Okay, and options are q by 8 epsilon 0, q by 4 by epsilon 0, q by 6 epsilon 0 and q by epsilon 0. Okay, so option right answer is q by epsilon 0. Okay, so to understand this, first we have to understand the Gauss law. Okay, Gauss law says that if we consider a closed surface and this closed charge link with this closed surface is q, then the flux with this closed surface is phi given by q by epsilon 0. Okay, so net flux for this closed surface is given by q by epsilon 0 according to Gauss law. But now see what happen when if we consider for the electric flux for only one surface of this cube. Okay, so one surface is actually 1/6 part of this cube. Okay, one surface is actually 1/6 part of this cube. So the flux related link with one surface. Okay, we are considering this surface. Okay, so flux link with this surface is 5 days is actually uh, 5/6, as this surface is 1/6 part of whole cube. So the flux link with this surface will be what? So it will actually q by epsilon 0 upon 6. So it will be q by 6 epsilon 0. Okay, so this is for actually flux related with any surface. Now in our MCQ we have actually charge on any vertex. Okay, so to understand this case, I am taking here some example. Okay, so consider this as a one cube. Okay, and this point is actually a charge, and this charge is actually 8q. Okay, so this charge is actually 8q charge, and that is placed on any vertex of this cube. Okay, so now according to Gauss law, okay, the flux, how can we give flux for any body? To give flux for any body, we have to consider charge in the center of any body. So okay, here 8q charge is not in the center of this cube. Okay, so to consider the charge 8q on center of cube, another 7 cube is required here. Okay, and how 7 cube is required? So to understand this, I have another 7 cubes. Okay, and I will put this like this. Okay, so one cube I will put in this side. Okay, second cube I will put here, third cube I will put here. Okay, so see, here actually I put another 3 cube, but this 8q charge is still we can see it. Okay, so now we have to put another 4 cubes to make this 8q charge in the center of cube. Okay, so how? So I have to put this 1 2 3 and 4. Okay, so now see here, total 8. Okay, total 8 cube required to make this 8q charge in the center of any cube. Okay, so actually here we have only one cube. So do so the flux link with this one cube is actually 1/8 part of main flux. Okay, so q dash is actually q by 8 q by epsilon 0, and divide by 8 is 1 cube is 1/8 part of that whole cube. Okay, so whole cube means the whole system of 8 cube. So here our flux will be what? So q by epsilon 0 upon 8, so it will be q by 8 epsilon 0. Okay, so wait, okay, this will not our right answer. If you see that q by 8 epsilon 0 and we get q by 8 epsilon 0, it will be not right answer. Okay, why? Because here charge is not q, charge is actually 8q. So here we have to write 8q instead of only q. So 8 will get cancelled. So our net flux for only one cube on which vertex has 8q charge is q by epsilon 0. I hope you get the idea. Okay, so we will meet in next video. Till then, keep studying.